Okay, so I'm sure you've seen this, just the easier ones in grade 9, probably. Okay, so but when we add or subtract fractions, okay, it's very different from when you multiply and divide them. Because when you multiply here or divide, you can cancel out something at the top here and something at the bottom. If for instance, if there's an x minus 1 here, there's an x minus 1, but you're multiplying, then you can cancel them out, right? So you got to be careful when it comes to adding and subtracting fractions. You can't do that at all. The main thing to do when you see adding or subtracting fractions is to get the same denominator. Okay. Remember we learned that, like if you just think of a basic thing like 1 over 2 plus 1 over 3, and we say add them, okay? You would have to say multiply this by 3, multiply this by 2, you get 3 over 6, so 3 over 6, plus 2 over 6, and then it becomes 5 over 6. You see, so you always have to make the denominators the same when you're adding or subtracting, because then you can combine it and say 2 plus 3 gives you 5 over 6, and the denominator then stays the same. So one of the mistakes learners make is they add the denominators as well and say 6 plus 6 is 12. Okay, but you obviously can't do that. You get two denominators and you make it one denominator because you get the same denominator, you just make it one fraction. Does that, you guys remember that? Eh? Mm-hmm. Now look, we're just going to apply exactly the same rule. We're just going to say, okay, now we got an xy and y and a 5x squared. We have to make them the same before we can make it 1. So this one has an xy, this one has a y, this one is 5x squared. So we're just going to multiply this one by y. Okay? Now it's 5x squared y. This one is xy, so we're going to multiply it by 5x, both sides. Now it's 5x times x is 5x squared y, the same as this one, 5x squared y. This one only has a y, so we're going to multiply it by 5x squared. Now, all of them have exactly the same denominator, 5x squared y, 5x squared y, 5x squared y. So we can now make it one denominator, 5x squared y. And we're going to have quite a big numerator. 2 times 5 is 10x. 3 times 5 is 15. X to the power 3. And then it's going to be plus 2y squared. And then you're done.
Isn't it minus?
Oh, sorry, yeah, there's a minus. Thank you. So that's it. You are done. 10x squared minus 50x squared. So you can't add these ones now. They're not similar terms. And you got one denominator, so that's it. And you can't even factorize it, like take out a common factor here. So that's it, that's the answer, you simplify it. So the big thing was to get the denominators the same and then combine it. So let's look at something like this. When you get questions like this, the biggest mistake that I've seen learners make, don't do this, is they want to make the denominators the same now, so they multiply this side by this side. They say, let's put this in brackets and multiply it by this one both sides. Let's put this one in brackets and multiply it by that one both sides. It kind of makes sense because, I mean, if you think again of something like 1 over 5 plus 1 over 4, so I'm going to multiply 4 here, and I'm going to multiply the 5 there. So I understand why learners want to do that, multiply this whole thing, but it doesn't, it's just way too long. That's not what we want. So what we want, with simplifying fractions like this, what we want is to always first see if you can factorize it. Okay? It just makes it so much easier. So you first check, what happens if I say here, I can factor, oh yeah, I can, x minus 2x plus 1. Okay? Negative 2 times 1 is negative 2, negative 2x plus 1x gives you negative 1x. So I can factorize this. Okay? And I do the same here. I first check if I can factorize it, and I can. I can say it's plus 2 over x, x plus 1. So I've found a common factor there, x. Here I used the normal factorizing for trinomials. And now it's easier to see that this one has an x plus 1, this one has an x plus 1, this one has an x minus 2, this one doesn't. So this one, to make the denominators the same, I need to put an x minus 2 on this side. So I'm going to put an x minus 2 over there on both sides, x minus 2 on both sides. And this one, what does this one not have? That this one has x. So I'm going to have to put an x on this one. So I put an x here, and then at the top you multiply by x. Now they look exactly the same. X, yes. X plus 1, yes. X minus 2, yes. So now I can say, make it x minus 2, x plus 1. And now at the top it's going to be 1 times x is 1x. 2 times x is 2x. And 2 times negative 2 is negative 2. And then obviously I can... Sorry, negative 2, yeah. It's negative 4. And then we're going to say x plus 2x is 3x. And then minus 4. So I'm just going to write it here. 3x minus 4 over x minus 2, x plus 1. And there's the answer. It's been simplified. And you leave it like that. That's it. You don't do anything after that. If here, let's say here, you could take out a common factor and find another x minus 2 or something, then you can cancel out. But here, there's nothing you can do after that, so that's the answer then.